Back to physics class, reflection at curved surfaces. In the previous class we have discussed about focal point in case of convex mirror and concave mirror. Now we are going ahead in the topic, like where we are going to see what are the different kinds of images, means how the images, whether the image is inverted or straight like erect, real, already we discussed about real and virtual images. Real means an image which can be caught on a screen, where image can form on a screen. Virtual means we only feel as though there is a change in the image, or as though the image is formed. Okay, so now we are going to see what kinds of different images formed by concave mirror. What different images are formed by concave mirror. For this, just a small activity. If you have a mirror at your home also you can do it, or when you come back to the school you can do it in the lab. Okay, right. Now here, just take a meter scale, put it on the table. With reference to the meter scale, now you take a V stand. We call it to be V stand, a wooden stand. And some of you have seen even in earlier optics lab activities, the V stand, where you will keep the mirror and the lens. So on that mirror, which mirror we are going to take? We are going to take concave mirror and an illuminated object. Illuminated object, it could be a bulb with some mesh or anything, or else you can take a candle. And then a screen on which you wanted to capture the image, on which you wanted the image to be formed. Precaution must be taken in such a way that the axis of the mirror, that is the principal axis of the mirror, should align with the base of the illuminated object. And then this one, the screen should be just below the principal axis. Below the principal axis. This is how you arrange. Why? Because why do you need it to be just below? See, the ray falls here and then the reflected image falls here. Hence, care must be taken that the screen should not obstruct the rays coming from the illuminated object. It should not obstruct the rays coming from the illuminated object. Okay, so now just we have a concave mirror in our hand. We don't know what its focal length is. There are two ways of doing this one. You can just simply take something like 60 or 70 centimeters of distance between the object and the mirror. You can take this screen from here and keep moving away from it, so that you can capture different images. That is one method. Or else you can find the rough focal length of the mirror before itself. How to find out the rough focal length? Yesterday we discussed. We keep the mirror facing the sun and we see that the image is formed, a bright spot is formed on the screen. Where it is formed, that distance is the focal length from the mirror, right? Is it not? It is formed at the focus. We discussed it yesterday by taking a small piece of paper on the way of the reflected rays from the concave mirror. So likewise like this, if you draw the ray diagram, it would be like this. That means the parallel beam from sun coming and falling on the concave mirror. On reflection they pass through, the reflected rays pass through the focus, because these two are parallel to the principal axis. And here the image is formed. Image I is formed at which point? At the focus. So you know now the focal length, the distance between the pole of the mirror and the focus gives you the focal length. Then after determining the focal length, you can start doing the experiment, like keeping at different places away from the focal length and between the focus and the mirror. It's up to, like when you are doing, you can do in these two methods. In your textbook it is given that take this screen near the mirror, and as you are moving away from, you will see different kinds of images formed. Different kinds of images formed. See, until we reach to the focal length, you can't see the image here on the screen. That means starting from the mirror, as you are moving away, until a particular point, you will not be able to see any kind of image on this, and that will be like seen inside the mirror, but you can see that image inside the mirror, but not on the screen. So such thing is virtual image. Now when you keep it exactly at the focus, what happens? Exactly at the focus, right? If the object is very far, when you keep this here at the object, you can see like that there is a bright spot at the focus. It is bright spot, and as you are moving away from it, different kinds of images will be formed. You can see that it is an inverted image. What observations you will be making while doing this experiment, that can be drawn as ray diagrams. Okay, so just after performing this, you need to fill a table, like where this illuminated object is located and what kind of image is formed here. We are fixing this one. Only thing is that you are going to move the object at different locations of the object, how the different images are formed. This is what we are going to discuss here now in case of ray diagrams. Okay, so here what you have to do, just only take from here and just take the readings wherever there is an image, a clear image. Sometimes at a particular point there will be a very small image that we call as a diminished image. What is that called? Diminished image. Very small image but clear and inverted. Then after moving some more distance, you can see that the size of the image will be increased a little bit. Again, adjust the screen in such a manner that exactly where it falls clearly, there you fix it, take the reading. Then as you move away from, you can see at a particular point exactly the same size as that of this. The same size image as that of the object is formed on the screen. Then still further if you move away, then you can see that there will be again an increase in the size of the image. So what's happening here? Slowly as you are moving away from here, starting from focus, that means starting from the point where you can see a very bright image, very diminished image, from there the size of the image will be slowly increasing. At a particular distance, the size of the image will be equal to that of the object, and again still furthermore you are moving, then the size of the image will be increasing. Okay, so now what you have to observe is, right, how to draw the ray diagram for this. After the study of the ray diagrams, when we will come back here, you will be able to understand what kind of things images will be formed here, and it will become easy for you to fill the table also. It will become easy for you to fill the table. Here though just we are only seeing the experimental setup of it. After performing the experiment, it will become very clear. See, now coming to the ray diagram location. So for rough focal length, where are we taking rough focal length? From infinity, that is from sun. Rays parallel to the principal axis are focused on this. After reflection, they are converging at a point focus, and the image is formed at that point, and the image is formed yet at that point. Okay, what kind of image is formed? The image is I, which is diminished, right, inverted and real. It is inverted. You can see that it is inverted here. But in case of sun rays, you can't see that to be inverted because you will see a spot, that's all. Okay. In case of like when you are determining the rough focal length, facing the sun, then you will only identify a bright spot. But if you perform the experiment here, keeping the distance between the object and the source very long and then moving the screen away from this, then you can see that there is an inverted image formed. See, candle is seen upside down. It is seen upside down. Right. So here the image formed, therefore we establish as diminished image, like inverted and real. It is diminished, inverted and real. Now after this we will go with different cases. Right. So now we will see that when the object is, right, when the object is beyond C, beyond C, C being center of curvature, C being center of curvature. So here, how many times you may repeat, with whatever mirrors you may repeat, you can see that always this F, that means this point of convergence will lie exactly at the midpoint between P and C. What does it mean? That means if PC is the radius of curvature, is it not? If this is center of curvature, a point on the curvature, distance between point on curvature and center of curvature is the radius of curvature. If R is the radius of curvature, then this is focal length as well as this is also equal to the same value, same size. So R is equal to 2F because this is exactly in the midpoint between the two. So what is the relationship between center of radius of curvature and focal length? Radius of curvature is twice the focal length. The radius of curvature is twice the focal length. Right. So now when the object is beyond center of curvature, this is what we are going to do. So now let us see that. Take a concave mirror, right? This is the principal axis, pole, focus, center of curvature, basic things, right? Now we are going to imagine an object over here. Illuminated object. Which kind of object? Illuminated object. That means it should be bright. The object should be bright. Then only you can easily do the experiment. Okay, so therefore it is an illuminated object. Now we have to draw the ray diagram. Right. Before we start drawing how the rays will pass, let us see certain rules of how to draw ray diagram. Let us see the rules of how to draw the ray diagrams. See, already we have seen one rule here. When the ray passes parallel to the principal axis, on reflection, always the ray passes through the focus. On reflection, the ray always passes through the focus. That is the first point. So that means rays falling on the mirror parallel to the principal axis will pass through F after reflection. After reflection. Some of you are saying only till here, pass through F. What are they which will pass through F? So they are like after reflection. That means the reflected rays pass through F. Right. And the second one is rays falling on the mirror drawn through F will travel parallel to the principal axis. Suppose if I take that there is a ray which is incident like this. How? It is incident like this. I will explain you here. It is like this. So this is the incident ray. See here it is parallel to the principal axis. This is the incident ray. This is reflected ray. So this is incident ray. Obviously it reflects parallel to the principal axis. It reflects parallel to the principal axis. Symmetry. See here if it is coming here and here means the converse is also possible in case of light. It takes the same path again. So from here the light ray is incident. It reflects in the direction parallel to the principal axis. This is the second rule. And third one, rays in the direction passing through center of curvature will reflect back along the incident ray. Means, I'll explain you that. So what does it mean? See, this is our center of curvature, right? Suppose if I have a ray like which is incident like this. In which direction it is incident, my dear? Children, in the direction of the normal. Is it not? Because normal always passes through center of curvature. So when the ray is incident along the normal, it reflects back in the along the same path. It reflects back along the same path. See the beauty of science or nature rather. Okay, see so you are like when the normal passes through the optic center, in that direction if the ray is made to fall on this concave mirror, then the reflected ray moves back or the ray takes the same path but in the opposite direction. Right? So this is the third rule. So using all these rules, now we are going to draw the ray diagrams. Using all these three rules, we are going to draw the ray diagrams. Clear? Okay. So let us start with this one first. So what is the first case that we have taken? Already one is done. Rough focal length means just taking the object at the infinite distance and then casting the image at a particular point. Obeying the rules here, a ray which is parallel to this should pass through the focus after reflection. So I have taken two rays here, they converge at this point, therefore image is formed here. The kind of image is, it is diminished, inverted and real. It is diminished, inverted and real. Inverted, you can see the diagram here, upside down. Okay. Now the other case, when the object is beyond C, now we are bringing the object from there to near to somewhere C. C being center of curvature. Okay. So let us take two rays always to make the to make the diagram easy. Okay. Right. So let me take one ray from the object parallel to the principal axis. Parallel to the principal axis. And one more ray which is passing through the focus, because infinite rays will be coming out. So we are taking only two rays. You can't take all infinite rays and then say that, ma'am, I couldn't come to a conclusion. Of course, first of all, you can't draw infinite rays in this space. Right. So another ray here. Which rays we have taken? So this is our object. From the object, that is from the head, so from the tip of the object, you are taking one ray which is parallel to the principal axis and the other ray passing through the focus. And the other ray passing through the focus. And here now don't again start drawing the normal and then measuring the angle and all that, because already after studying all that we have come to these conclusions. So let us apply these things directly. Okay, let us apply these things directly. Don't think that by doing this we are violating anything. No, after satisfying those conditions only we have come to this. So always the reflected ray makes the same angle as that of the incident ray with the normal. It is fixed. So there is nothing to discuss on it now. So based on those rules only we came to these conclusions. So now what we are going to see? First rule. A ray falling parallel to the principal axis on the mirror will pass through the focus after reflection. Alright. First ray. This first ray is parallel to the principal axis. After reflection, it is passing through. It is passing through focus. This is the reflected ray. Okay, clear? Right. Now let us see. So first rule is applied. Now go for the second one. Falling on the mirror through F will travel parallel to the principal axis. See, on the mirror, the ray is passing through the focus and falling on the mirror. The ray is passing through the focus and falling on the mirror. Then how the reflected ray should be? Reflected ray should align itself parallel to the principal axis. So draw a line from this point parallel to the principal axis. Parallel to the principal axis. Please take care. These are rays. Right? These are rays. So to avoid confusion, let me write this one as F here and this is C. Okay? Right. So how are the rays here? This is a reflected ray and this is another reflected ray. They are meeting at this point. They are converging at this point. That means from both the directions. From here one ray is coming, from here one ray is coming, and they are meeting at this point. Right? At this point. So here the image is formed. Here the image is formed. How the image is formed? Inverted. The image is formed inverted. Can you see the size? Size of the object is more. Size of the image is less. Size of the image is less. Right. But here the almost point size image. So now the image size is increased. After the focus level, between focus and C, between F and C, the image formed is always greater than that formed at F. So I will write this as IG, image. I. So the image I is again smaller than. What kind of image is formed? Image formed is. What kind of image? Smaller in size. Smaller in size. Inverted. Can you see that it is inverted? And real. And real. Inverted and real image is formed here. Okay. So pause the video for a moment and please try to copy these rules and these two ray diagrams so that we can continue with the next case. Clear? I will repeat this once again. So take a concave mirror. This is the principal axis, pole, focus and center of curvature. Now where are you locating the object? The object is located at a finite distance. Here the object is at infinite distance. Here it is at some finite distance far or away from center of curvature. That means a little bit far distant from mirror. Right. Now we are taking only two rays here to make it more convenient to draw the diagram. So one parallel to the principal axis and the other ray passing through the focus. You have to draw like this only. Please don't draw curve here, straight line here and then all these lines and then finally this line. No, not at all like that. So these two rays. First ray parallel to the principal axis. As per the rule, it should pass through the focus. See, the reflected ray is passing through the focus. Second rule, when the ray is incident in the direction passing through the focus, then the reflected ray should pass parallel to the principal axis. So this is the reflected ray here. Now these two rays are meeting at this point and therefore the image is here. That means from the principal axis to this. As how you have taken the base of the illuminated object is always on the principal axis. The base of the illuminated object is always on the principal axis. Similarly, here also you can see that the base of the image is also on the illuminated object. The only is also on the principal axis. The only difference here is this is above the principal axis. That means it is erect and here the image is down. That means inverted. The image is inverted. So you got the kind of image is smaller in size, inverted and real image. Real image means here on the screen you can capture this. On the screen, whatever you are taking this screen, right? So therefore that could be a paper or any other thing, opaque screen, and then on that you can take this image. Clear? Yeah, please copy down this one. As you are copying also, please follow the same rules and the instructions like how you are supposed to draw the diagram, right? Both the cases. Pause the video for a moment. Done? So now the next case. When the object is yet to see. So here we have taken the object beyond C. That means this is the center of curvature, and beyond this you have taken the object. Now we are bringing the object a little bit more closer to the mirror. See, previously we have taken an infinite distance. We moved it to finite distance. Now we are coming closer to the mirror and we are keeping the focus, object on the center of curvature. So, concave mirror, principal axis, pole, focus, center of curvature. Okay, so now where is the object? Object is here, yet center of curvature. I will write the name as OJ, object. At which part? It is at center of curvature. At center of curvature. Again, same rules. Take two rays. One ray parallel to the principal axis. Another ray passing through the focus. Another ray passing through the focus. Okay. Done. So, two incident rays we are taking. Now, the first ray, which is parallel to the principal axis, upon reflection must pass through focus. Must pass through focus. And now, this is the reflected ray. Second ray. What is second ray? The one which is incident on the mirror. See the direction of the ray. Which is incident on the mirror passing through the focus. Should pass parallel to. So I think my focus location is a little bit away from this. Not exactly the midpoint. Yes, I am missing that one. So let me redraw this again. So care should be taken that you have to locate focus exactly at the midpoint between C and F. If this is C, let me approximately take it. Right. So this is the object. One ray parallel to this. It should pass through the focus. The other ray passing through the focus should get reflected back. Still more. See, when you are drawing with the scale, you will get that. Right. Almost done. Right. So, here this is a reflected incident ray. This is another incident ray. This is reflected back based on the first principle, and this is reflected back. And the rule followed here is the second rule. Now, you can see that at the same location the image is formed. That means at the C you have put the object OJ. And the image OI is formed here. The image is formed at the same point. Of same size. It should be same size. It will come out to be same size. Please remember this. And then when you use scale and draw, you will absolutely get of the same size. Okay. So what is the kind of the image you got? Image kind is same size. Real and inverted. Real and inverted. What is the meaning of real again? In the previous case, on the screen you can capture this image also. As I said, as you move away from the mirror, at a particular point you can see that the size of the image is equal to size of the candle's flame. Okay? Right. This is the case when the object is at C. That means at center of curvature. Now let us see the next one. Case 3. Let us bring the object a little bit some more nearer to mirror. Means between F and C. So these are all acting as reference points to us, is it not? Right. Now draw a concave mirror. Principal axis. P, then F, okay, approximately C. Center of curvature, I think I am moving away from this, right? So let me take my curvature to be a little bit bigger, right? And now object is placed between F and C, right? Object is placed between F and C. This is the case. This is the third case. Okay, right. Now same rule again. One ray passing parallel to the principal axis will get reflected back through the focus. Another ray which is passing through the focus will move parallel to it. It is supposed to, I think I am unable to draw a straight line here properly. So let me fix it. First let me draw both the lines, then I will fix the focus. Because I am drawing it here, it is slipping. Right, so let me locate the focus to be here. Okay, right. So now this is the reflected ray. And here this is the reflected ray. Where they are meeting? Here they are meeting. Okay. So but see, we got it to be here of equal size. We must get magnified. So where is that? This is the focus. Oh, this is, see, very wrong location of focus. Okay. So you need to practice this, and also please, while drawing with the scale, exactly put the focus between these two. Right. Is it? Let us suppose. Right. Now the object is here. Right. This is the incident ray. Let the ray go like this. Okay. Now this like this. And right, somewhere here the image is formed. This is the incident ray, this is reflected back, passing through focus. When you locate the focus exactly, you will get the image exactly. And this is the one which is parallel. So can you see, this is the object and this is the image. So that means there is an increase in the size. There is an increase in the size. We call it to be magnified